thank you everyone for joining. We're super happy to have everybody join. We've had a ton of interest in this presentation. And so without further ado, I'm going to hand it off to Michelle. That is going to be walking us through Magma, make some introductions, and I'll stay pretty much off screen here and let Michelle and the rest of the team talk you through about Magma and all the great things we're doing. So thank you. Michelle?
Thank you. Thank you so much, Doug, and welcome everyone in our audience. We really appreciate your time and your willingness to hear us talking a little bit about Magma and our efforts with the open source community and efforts to make connectivity available to everyone at a much lower price point. I'm Michel Castaldelli. I'm responsible for partnerships at Facebook, basically global partnerships with system integrators and local partnerships in North America with WISPs and service providers. We also have here with us Boris Rensky, who is CEO and co-founder of FreedomFi, and we have also Kader Khan, who's going to join us in video in a moment, and he's Senior VP of Connectivity and Industry 4.0 for Wavelabs. Each of us are going to do a presentation that's going to take 15 minutes, and I will enforce the time because, I mean, we only have 1 hour, right? So we want to have at least 15 minutes to answer any questions from the audience. If we don't have time to answer all of the questions, you guys are welcome to send us questions via email or via any other means. We will also make the materials available so that you can ask questions later on if you so desire. Doug, do you want me to share the material from my computer, or are you going to share the slides from your own machine?
It should be sharing if you can see the screen here.
Let me see. Oh, yes, I can see it now. Hope everyone in the audience can see as well. So if you can move one slide. I'll start by telling you guys a little bit of why Facebook's doing this. Facebook has a lot of initiatives in connectivity. And on one side, we are doing this because we need it. Like network performance, we see it as at risk. There's 3.3 billion in developing and emerging markets at risk of facing degraded network performance by 2023. And that's not good for Facebook. I mean, our mission is around community, and we need people to be connected to be part of the community. So connectivity for us, it's something very important. It's something that we do on one of those rare occasions where there is a major alignment between our mission, what we do for a living, and what is good for society, what is good for humanity as a whole, right? So it is at the heart of everything we do, to give people the power to build more communities and bringing the world closer together. We want to do this by several different ways, taking connectivity to people who are unconnected, improving connectivity to people who are underconnected, and improving the profitability of our partners who are vendors and people who are providing services to their communities, right? By reducing the TCO of the infrastructure and of the software that's required to provide this kind of infrastructure, this kind of solution. So if you look at all the different activities that we do, we have a lot of different projects. We have projects around millimeter wave, projects around Open RAN, projects about data center infrastructure, about networking sites, a lot of different ones. And Magma is one of those. Magma, it's an open source core network, 3GPP core network. If you can move one slide, Doug, please. That we started doing in 2015 when we acquired a company that had an initial code base for an open source core called Endaga. That was in 2015, and we've been working on it ever since. Then this year, we actually decided to move all of that code base and move the Magma brand, move pretty much the entire project to the Linux Foundation. So now the Linux Foundation is behind all of this code. And we have Magma as an open source community solution that was always the case, but now managed by the Linux Foundation. apart from the Linux Foundation doing the governance of all the Magma code now, we have community outreach being done by the OIF, and we have technology from the open air interface as well. And what is Facebook doing now? We are still doing what we used to be doing, like contributing software engineering and writing code and listening from our partners, where exactly can we develop more things and what else we should add to Magma. And we are also, from another side, taking the Telecom Infra Project Initiative, TIP, with talking to service providers around the world and collecting those use cases and those requirements and building blueprints on how you can use Magma and other open source cores, right, to make the world a better place, right, make the world better connected. That's basically what we are doing. Magma, as I was saying, it's code that's available for a long time. It's like we started working on it in 2015, and we've been maturing the code ever since. And now we reach a point where we feel like anyone can benefit from what is already there. It's fully functional. There are many networks already operating using Magma as their core. And the moving it to the Linux Foundation, we see it's only going to improve this kind of community participation, right? We expect to see more and more people contributing to the code and using it to different use cases. On the next slide, talking about use cases. Initially, when we developed Magma, we were looking into fixed wireless access. So our idea is like, is it possible to make a core that's small enough that's going to make it viable to offer a connectivity in isolated communities, where, for example, backhaul may not be as reliable for you to like connect node Bs to a core that's miles away, right? I mean, any hiccup on the backhaul can cause people to detach, right? And like a traditional core doesn't work as well in that scenario. So we started creating Magma with that in mind. Let's start doing fixed wireless access. We have a few deployments there, even like in very difficult or challenging environments like tribes of Native Americans and things like this. Then we went onwards to adding other use cases. So carrier Wi-Fi, for example, you can use a single core to authenticate users on a Wi-Fi network using SIM cards. Then private LTE and neutral host, same thing, one more use case. We quickly realized that the same features that let us be a very attractive option for fixed wireless access can help us in the private LTE world, in the neutral host world. So all of a sudden, like if you are covering carpeted spaces or facilities, venues, or even a factory with 3GPP coverage, right, with LTE coverage, you could also benefit from a very small core network there that's available locally, and it's not dependent on connectivity to something external, right, on a like super reliable backhaul. So that's also one more use case that became super attractive all at once. And then this year, we are actually focused on improving on these use cases and bringing in more functionality. So what is coming next for us is full mobility. Nowadays in Magma, we have already some sort of mobility, like you can have handovers between users connected to the same access gateway. I'll talk a little bit about the architecture in a moment, but no mobility between access gateways. And that's what we are working on our use case number 4 there this year. And we are also working on 5G. So our goal is to have, come September this year, 5G standalone core ready for deployment. And we already have prototypes of this that you guys can access on the GitHub code base and start playing as well with some of the 5G functionalities. 5G non-standalone option 3A, it's available right now. It's supported on our release 1.5. And option 3X NSA and standalone is going to be coming on our new release 1.6. Next slide, please, Doug. This is the Magma architecture in a nutshell. So what guides us to create this architecture is how can we make 3GPP technologies, right, LTE and 5G, as easy as Wi-Fi? Like a lightweight core, very simple to deploy, right? How can we benefit as well from the nice things about the open source community, right? Zero licensing costs, so reducing the TCO a lot, and very fast pace of innovation, right? With contribution from a very active community. This is also completely vendor and transport agnostic. I mean, it speaks standard 3GPP interfaces towards the radio, right? So S1A for the E node B, and N1 and 2 and N3 for G node Bs for 5G. And on the other side, you can see there out of the Federation gateway, it speaks S6A and diameter, right? GX and GY to integrate with an existing MNO core. Everything you see in between is done using standard HTTP2 interfaces, right? HTTP2 APIs. So it's a lot easier to understand, a lot easier to implement than going full-blown 3GPP interfaces for each of the network nodes, right? For each of the network functions. This architecture also provides a full local breakout for internet traffic. So everything you see in the bottom part of the picture from the radio passing through that box that has LTE, Wi-Fi, and 5G that we call an access gateway, and it exits XGI or N6, all of that, it's deployable in a very small box that you can put at the very edge, and it provides a full core with local breakout. It talks the standard REST APIs, the HTTP2, to an orchestrator that you can put either in the cloud or you can put in like an on-prem server if you want. And the orchestrator orchestrates all of the access gateways and make them look like it's a single network. Okay, you can get access to these REST APIs. They are well documented, and you do whatever you want with them, like get information for billing or for provisioning or whatever. But if you want to connect to a standard 3GPP core, for example, roaming for an operator, let's say Verizon or AT&T, you could deploy a federation gateway that translates these REST APIs into standard 3GPP interfaces as well. So this architecture allows a lot of different use cases. I'm not going to go into details, but in the slides that are going to be shared with you guys, there are blueprints for each of these other use cases that I mentioned: neutral host and private networks and fixed wireless access, how you can do structures with multi-tenants, etc. On the next slide, you see how we are actually doing this. Facebook itself, we are not selling anything. We cannot really even accept a PO if some of you guys would like to hire services like this from Facebook. I mean, we are purely a cost center. We are creating this for the reasons that I mentioned before. And we are relying on an ecosystem of partners to actually sell this either as services or sell hardware that incorporates Magma, or they are just our technology partners. So you can see a few examples here in this chart. We have partners that are, for example, manufacturing radios like Blink and VNL and Bicells, right? And then we have other partners who are system integrators, and they can do everything from just doing an initial installation to doing a full managed services project with anyone that's interested. In those two, we can categorize Freedom Fi and Wavelabs, who are going to talk to us a little bit about their offers. And then you have a few others who are technology partners, like ARM, for example, who is helping us migrate all of the Magma code to running on ARM-based machines, right? And then we have SSH and Amazon Web Services, for example. You can go on Amazon Web Services and spin up a machine that runs Magma based on images that are already available, ready to go, right? And some other companies like Freedom Fi offer something similar as well, even going towards the hardware, right? So a lot of different possibilities with this solution. That's what I wanted to show you guys as a very quick introduction to Magma. We're gonna now jump to the presentations from Freedom Fi and Wavelabs, where they're gonna tell us a little bit more about what exactly they are doing with Magma. At the end, we're gonna be opening for questions. And as I mentioned, feel free as well, if we don't have time to go through all the questions, to get in touch with me, with Doug, or with any of the participants here. Thank you. Boris, I'll hand it over to you. Boris?
Boris, I think you're on mute.
Doug, maybe you have to unmute Boris yourself as the host.
I think so. Oh, looks like he just dropped out. I wonder if it makes sense to, as we wait for Boris, maybe have Kedar present if you're ready.
Yeah, we can do that. Do you want to make me as a presenter, please? You did. Thank you. Check here quickly. Can you see my screen?
Yes.
All right. Okay. So, sure. Just a minute. Can you see my video? Actually, yes. I guess. Let me check here. All right. You're good to go. Thank you, Michael, for the introduction, Doug, for organizing this awesome session. I'm really very privileged to be here, sharing floor with Michael and Boris. I was supposed to go last. I happened to go second. I think I got a little bit lucky today. What I'm going to do today is, in next 15 minutes, I have planned to talk on 3 topics. I'll start with a little bit of introduction about Wavelabs, followed by little technology aspects of Industry 4.0 private networks, and finally end with a deployment model. So if you look at it, I've kind of spent more than many years, I would say more than 2 decades in telco space, helping building products and solutions. We have always been exceptionally good when it comes to networks and management aspects of it, but when it comes to transforming the product to cloud native, CI/CD, DevOps, digital and cognitive, we always had challenges. Let me put it that way. I'm sure pretty much you are all able to relate what I'm saying. Learning from that, what we did was in Wavelabs, we built ground up with the teams that has the combination of digital, cognitive, and network expertise to help our clients who has or have similar challenges as I spoke about, to accelerate their journey towards the future connectivity by providing advanced technology services and solutions. Okay. Doug, just to make sure slides are changing, right?
Yes.
All right, thank you very much. All right, so the other strategic decision that we took is to embrace open source, open networking. The simplest way probably I could put it as anything and everything to do with open technology we wanted to embrace as Wavelabs. And at Wavelabs, we call it as an OpenX. Why? Because we strongly believe OpenX ecosystem enables unprecedented innovation, agility, and even time to market. First of all, I really wanted to thank Facebook for the opportunity. We have been contributing to the code base of Magma more than a year now, and leveraging that strength. In addition, as an implementation partner, we are also have been helping vendors building use cases leveraging Magma, as well as service providers in testing and deploying proof of concepts and commercial fixed wireless access, carrier Wi-Fi, and private wireless access network, as Michel was talking about in his slides. So end of the day, our goal in Wavelabs is to really help industry realize the vision of open and disaggregated white box connectivity products, solutions, and network a reality. And we believe that mindset, it matches pretty much to the goal of Facebook, and we are glad to be their implementation partner. So our OpenX approach, sorry. Apologies here. Okay. So, throughout having worked and also with experience, I've realized 2 things. One thing that I've realized is one size does not fit all. This is not something new, but it is real. And also, no matter what, there is always something new, something unknown, and untrodden areas that we always have to deal with. And especially in the world of OpenX ecosystem, given the variables that we are dealing with, right? Like open hardware, open infrastructure, open network functions, open core, open RAN. I mean, it is 200% or more true. So what does it mean in practice? From my point of view, it means in practice, to make it all work, you really require an engaged, committed, and collaborative partner who is willing to put skin in the game with a shared roadmap, vision, and successes. The partner who takes care of all complexities and challenges from you and let you focus on your customer and your business. That is what we really strive to achieve with our clients, depending on their use case. At Wavelabs, we help them leveraging design thinking, that is one use case at a time, and using agile methodologies to help them choose right deployment model, whether it is a standard deployment model that we have already tested or a custom one that they need. And second thing that we really help them to do is choose the right infrastructure, because there is different use cases might require different types of infrastructure to be deployed, either supported by Magma today and even the new infrastructure that they wanted to explore. And finally, we pretty much take care of the rest. If they wanted us to add some additional features, for example, DPDK to improve the performance of the user plane, and system integration with third party or managed services end to end, right? We pretty much take care of that. Slide K. All right. So apologies here. There's some technical stuff. Okay. All right. So in this slide, what I wanted to really explain is not only we take care of consulting engineering, but we also take care of managing our client products throughout the life cycle, from intent to design to operations. It includes obviously the brain of the converged core network Magma and its integration with other domain like RAN, transport, OSS, and BSS. That brings to my first tip of the day. So the tip is always look for collaborative partners who is prepared to put skin in the game for mutual win-win successes. All right. I'm pretty sure you have seen this diagram multiple times. But today what I'm going to do is I'm going to really focus from the network point of view. I wanted to draw your attention to three keywords here. Right? The first one is the business-driven communication, meaning the communication that really helps to run the business effectively. Example, voice, emails, and the apps that we use, right? The third industrial revolution was all about that. It helped the growth of many service businesses and industries, just to give you an example, such as finance and media. And the second word that I wanted you to focus is business critical communication. It basically helps to run the operations without any downtime, right? Manufacturing operations as an example. If there is a downtime, think about it, right? In airport, factories, or in mining, the businesses tend to lose money, right? So it is very critical from that point of view. That is why it's called as business critical communication. And the next one is mission critical communication that really help us all alive. Right, a good example would be train control, public safety services, even power plant and grid control, and so on. All right. So now, when you talk about Industry 4.0, it is all about advancing and enabling these three types of communications that I talked about. Right, some of them are new and some of them are existing. And the dedicated private wireless network deployed for exclusive use for its unique use case requirement is key towards the success, right? And also you can see in the picture, 4G and 5G together with other technologies like Open RAN, Edge, AI, IoT can unlock the potential of automation, control, and exponential growth for various industries and its application. And that's the promise of Industry 4.0. So 5G for Industry 4.0. It's actually an interesting topic indeed, because there are different views. I'm pretty sure even you have been hearing about, right? Just to give you an example. Apologies. No, why is it doing it here? Okay, just to give you an example, right? Few say that many industries are looking at 5G as a backbone for Industry 4.0. And I've also heard that many say that, enterprises really don't care about 5G because it's just another technology. Well, as of today, I'm going to focus on the technology point of view. And if you think from the technology point of view, the 5G is designed and developed and under development to address all types of communication requirement, business driven and business critical and mission critical communications that we talked about in the previous slide. To really serve high throughput broadband, low latency, and massive type industrial use cases. To explain this further, I put together this particular slide. If you focus on the picture in the left and also in the middle, you would see that in the bottom, OT domain, right? So what is OT domain? OT domain is nothing but a manufacturing floor with sensors and actuators in the industry enterprise, right? The business critical and mission critical communication is applicable here. So naturally, enterprises prefer to isolate the complete network, and not only the network, right? They also try to historically isolate the manufacturing systems like MES, services, apps, and operations from other domains. And the next domain that you see in the picture is the IT domain, which is an enterprise IT domain from the third industrial revolution that I talked about, right? Here, mainly the business-driven communication is applicable. Here, most of the applications like CRM, supply chain management, and many other enterprise applications are hosted here. And finally, you have the public domain that connects to the internet or service provider network. Now, in Industry 4.0, it's all about taking automation to the next level. 5G is believed to enable number of use cases across various automation areas, as you can see in the picture to the right. Some use cases, such as like predictive maintenance, process monitoring, require high throughput, and others like some of the mission critical things require low latency and massive connections. So that's my second part of today's session. That brings to my second tip of the day. The tip is, 5G is important and will be superior. However, I wanted you to remember that, it's always good to think in a design thinking way. Depending upon the use case requirement, 4G and even Wi-Fi may be good enough. Magma supports all three. All right, the on-premise deployment model. The slide that you're seeing here basically explains an on-premise deployment model for business critical and mission critical use cases. This is basically an OT domain, right? So in this model, the private network in OT domain is deployed completely isolated from other domains. Depending on the requirement, the design and the dimensioning can get real complex. I have provided for your offline reference few theoretical numbers. Maybe due to time limit, I may not be able to cover everything, but I'll be happy to discuss this offline with you all. But however, in this case, remember my first tip, right? There is always unknown, untrodden areas, and same size does not fit all. You require a collaborative partner to learn along the way to realize your goals. Another key message I would like to really share based on my experience is that I like to highlight just enabling connectivity between OT and IT enterprise is very powerful by itself. You can increase the productivity and do number of other things with it. And what you see here in this slide is on-premise deployment model for business-driven communication. The previous one was mission critical and business critical communication, and this one is business-driven communication. It is pretty much, like I said, similar to the previous slide, with an exception of providing private wireless network for enterprises that is not isolated like OT domain, but connected with internet and service provider network to avail some of the connectivity services like voice, IMS, and so on. And Magma supports this configuration really well. We have experimented that in many places, and it works awesome. Magma multi-tenant model, right? So this slide I've captured, which basically is applicable for both business-driven and critical communication use cases, right? It really helps when you have a requirement to connect multiple enterprise branches or manufacturing floor, and you wanted to manage and operate it from a single location. So that's where this multi-tenant model can become really handy for you all. So this, what you see here is the Wavelabs connectivity blueprint, and it lists different areas that we have been developing our expertise, working together with our clients by offering technology services and solutions. The Magma converged core as such is the centerpiece of it all. At first, I'm pretty sure at first sight, the blueprint might look very complex. I can understand that because it kind of captures end-to-end view. However, most of the deployments based on our experience requires very basic network and with basic OSS and BSS. Let's say with basic fulfillment and billing and revenue is good enough, and can be expanded by the clients to cover other areas and use cases and business case as it demands, right?
Hey, Kedar, hi, this is Doug. I think we're almost out of time on your session. If you want to maybe just get another slide and close your session, that would be super helpful.
Slide. Yeah, I'm the
Thank
last.
you.
Yeah, sure. So, anyways, that brings to my third and final tip of the day. So the tip is, it is kind of forecasted that spending on private and shared enterprise networks will surpass spending on public cellular networks in the next 10 to 15 years. And it is also forecasted that industrial manufacturing will spend the biggest. So you can do the math why all vendors, industrial vendors and service providers are all behind this big game. And Doc, this is my last slide, call for action. If you are an enterprise building use case leveraging Magma, or enterprise and service provider looking for proof of concept and commercial deployment, you know what to do. Connect with us and let us kickstart our engaged, committed, and collaborative partnership. Over to you, Doc. Thank you.
Fantastic. Thank you. And I know that Boris, he texted me, he dropped off. There was internet connectivity working from home, but looks like he's back. And if you are back, Boris.
I am back.
Awesome. So we will let you proceed. Do you want me to present or do you want to present?
I think you can present, and I will just tell you next slide. And again, apologies to everybody for dropping off in the middle of a presentation. My kid wasn't satisfied with the ping in his Fortnite and decided to reboot the router for the house. So
nice. All right. Can you see that?
Yes. Yeah. All right. Thanks, Doug. So before I dive into FreedomFi, I wanted to share a few words about why at FreedomFi we are excited about Magma in general, and maybe build a little bit on some of the presentation that preceded mine. So I think that the grand view is Magma is actually something that is quite unique in the big scheme of things, and that historically the evolution in kind of a compute architectures have always defined how the network architectures have followed. And we saw that as compute moved from mainframe to server PC computing, that was really the birth of networking, and that was the birth of IP networks. And what we have seen follow is cloud computing revolution that happened during the last 10, 15 years. And that defined a completely new networking pattern, which gave birth to SDN, or the software-defined networks. And what we're seeing now is most of the compute actually no longer happening, in the PC connected to the internet using an Ethernet cable. Most of the compute is actually in the handheld devices or wireless devices. And as we move into this paradigm, the networking architecture backing all of it actually is the, to date, still to a large extent, the traditional kind of a mobile network operator architecture, which really resembles more kind of a mainframe compute paradigm than anything that we have seen even in the cloud computing, and that it's usually built tops down. The architectures largely dictated by how the phone networks have historically been built, and are built in this kind of a monolithic way, where the specifics of the end devices actually bleed throughout the entire network fabric, which makes it very hard to maintain, scale, update, and operate in general. And what I believe that Magma is actually really, in my view, the first manifestation of the implementation of this, truly new networking paradigm, specifically that builds on everything that we have learned in the cloud computing space, applied to this new kind of a network compute paradigm of connected compute. And at FreedomFi, most of our DNA comes actually from the open source background. So prior to FreedomFi, most of the team, myself included, were working on building basically enterprise distributions of cloud computing projects like OpenStack and Kubernetes at a company called Mirantis. So our bread and butter is really open source, and open source generally is very disruptive when applied in certain areas or certain aspects of software development. And aside from Magma just being a perfect fit and a very dramatic deviation from everything that we have seen in the wireless networks before from the architecture standpoint, the fact that it's open source is also a way to apply the right economic model to building the software in the problem space that it's trying to address. And that if you in parallel look at how open source projects historically have evolved, the ones that have dominated were the ones that were looking to solve a fairly ubiquitous problem at the lower layers of the infrastructure. So we all know Linux being the most popular, operating system that runs pretty much everything in the world now. The reason why it's popular is because Linux, or the majority of it, is, the same server to server to server. There's definitely different distributions and permutations, and there's a version for mobile devices, etc. But the Linux kernel is a big piece that is reused very much the same way across everywhere. And then if you kind of project the same concept to other areas, like, for example, web servers or container orchestrators, then you will see that, the areas where it's a lower layers of infrastructure, this is where open source becomes dominant. And on the flip side of it, where open source doesn't work is where there's a hard coupling to the business process of the organization that's adopting it. Like, for example, there are not so many open source supply chain management systems or, very successful open source, customer relationship management systems. They do exist, but they don't really dominate the space. So Magma actually is very much like an infrastructure level component and is implementing the effectively the data plane or the user plane, as we call it, of the network core, versus focusing on the higher levels of the core that tie into the OSS and BSS stuff. And through this very focused application of open source development model, coupled with this very fitting architecture for where the world of compute is moving, I think is a winning recipe for Magma to become basically the Linux of the wireless network cores, which is why we're very big on it. Now, having said all of this, going to FreedomFi, open source, generally speaking, is a development sandbox, and you can deploy any open source project, Magma included, in whatever which way, which is both kind of a powerful concept, but also is a problem. And what we do is we pre-package Magma in a very particular easy to use way that we're ultimately able to support clients with. What we do is, next slide, please. We take a Magma access gateway, and we prepackage it on this generic x86 appliance that you have seen on the screen before. And we make it possible for folks to basically deploy an LTE cellular network using Magma in a very prescriptive and kind of free, easy steps. So if you click next a couple more times, we'll see the description of the steps. So you can buy, a commodity LTE small cell from anywhere, and there's a bunch of them that are sold now online, ranging anywhere from like $500 nowadays to thousands of dollars. Because Magma is access agnostic, you plug that small cell into this x86 appliance called Freedom Fi Gateway, and then you log into a SaaS portal and you set up your networking rules, import the list of your SIM cards, and your network is up and running. Next slide. And all of that experience is really powered by Magma under the hood, in that we are radio agnostic and you can use any small cell to plug in. Inside of the Freedom Fi Gateway is just, a hardened packaging of the Magma Access Gateway. And the SaaS portal that you log into is nothing more than, an orchestrator that we deploy and host for the customers online. Next slide. So we, apply the same exact model to a variety of different use cases, be that private enterprise networks or greenfield mobile network operators in, underconnected countries, and also to the, WISPs and fixed wireless access use case as well. So a common way that people get started that are not familiar with the LTE is they just get, what we refer to as like this trial kit, which you see in the picture, just basically a box with everything that you need to build an end-to-end, single eNode B private network. Using Magma and this prescriptive way that we've described. And you literally with this are able to bring it up, in usually about an hour's time of work. Next slide. So I wanted to close by quickly taking you through one of the recent fixed wireless access case studies. There is a public case study that was previously presented at the Magma Developer Summit for WeConnect Wireless, where they used this exact model that I've described to deploy a Magma-based fixed wireless access network. So WeConnect is a WISP out of Wisconsin, a pretty sizable operation actually, with over 200 wireless towers. Up until we got involved, most of the wireless towers were basically Wi-Fi point to multi-point, mostly ubiquity systems. And because of where they provide the service, there's a lot of trees there, and Wi-Fi 5 gigahertz doesn't go through trees very well. So they were looking to really expand their LTE network, but the complexity of it was just prohibitive, which is why they chose our path and working with Magma in particular. So next slide. So again, I don't want to say that if you are a WISP, then throw away all of your Wi-Fi and use LTE and Magma instead. There are pros and cons to both approaches, but focusing on the pros for LTE or 5G, one is, as I mentioned, is a much better no line of sight coverage. Much better control of basically quality of service policies that you can give to the individual subscribers, and a much broader ecosystem of the UEs, because unlike with the Wi-Fi systems where you put the CPE, you can actually get access to that same network with the cell phone. So anything that takes a SIM card, you are good to go. Obviously, there is slightly higher cost and a bit more complexity. Are the cons for LTE-based fixed wireless access networks. Next slide. So quickly going over the goals, what specifically were we working to solve for this fixed wireless access network in particular, and why Magma? So as you've seen from the previous architecture, Magma has this redundant, horizontally scalable user plane, in that you have effectively a Magma access gateway per eNode B that you deploy, which decreases your failure domain. So increasing the redundancy and stability of the network was important. Instead of home routing S1 traffic to a single choke point, which if it God forbid dies, all of your subscribers go down. Being able to separate user plane and control plane traffic by broadcasting by having basically multiple APNs. And another kind of important feature that we implemented is being able to assign an individual IP address to each CPE, which is publicly accessible, because oftentimes with fixed wireless access, you need to get into the CPE for the subscriber and either reboot it or see if something's wrong with the software, versus the traditional LTE model typically nats the network outside of the eNode B, which precludes you from getting into the individual CPE. So you can actually assign an individual IP address to each CPE with Magma, which is this nice feature. And then obviously the existing OSS BSS stack that the wireless service provider chose to use needed to be supported, which was Nagios for monitoring and the BioCell's OMC as the element management system for the BioCell's eNode Bs. Next slide, we're almost done. So, if you look at that particular network, like what it looked like in terms of broad pieces, you oftentimes see these big diagrams of what the LTE network looks like, and you can kind of see the same big blocks here. So the RAN part of it for this particular use case was BioCell's Nova 436Qs and the Atom Cat 4 CPEs. Core network was Magma, that is prepackaged the Freedom Phi way, and then the OSS BSS piece was a BioCell's OMC Nagios, and they use Sugar CRM for customer management. And the next, and I think, yeah, so this is the topology that we deployed. It's basically the butterfly topology with two sectors for each BioCell's Nova 436, which supports, it's a 2-carrier cell. So we had 1 sector antenna per carrier, which gives you this kind of a nice, pretty much 360 coverage that you can see right here. And this is how most of the sites were deployed. And the next and last slide. And this is a bit of a breakdown of the cost. So people always, and I'm not going to go line by line, but I think one of the big takeaways is people oftentimes say, well, I'm fixed wireless access, it's competitive market, very cost sensitive. I'm going to rather use, ubiquity point to multi-point system versus an LTE system, which costs $5,000 versus like $1,000 or $700 from ubiquity. Now, if you look at the real costs where they are, the cost of your eNode B is really just a part of what it costs to build a tower. And this breakdown right here doesn't actually, have any tower related costs. So this assumes that you have like a silo for free that you're renting from a farmer and you're mounting all of the equipment. With a tower, then it'll be, probably another $6,000 to $10,000 on top of the 10 that you see here to build the tower. And the point is that if you're investing in the tower, you might as well consider investing in something like a LTE, which gives you the opportunity to do this, fine-grained quality of service control, much better, no line of sight penetration. And, if you're able to get your hands on a licensed spectrum, which is common, particularly outside of US and emerging countries, then naturally you can get much, much better range with than with the 5 gigahertz Wi-Fi. So the point of the slide is like, a lot of people complain in the fixed wireless access world, oh, LTE is so expensive, I'd rather do Wi-Fi. In the grand scheme of things, if you look at the total BOM of the tower, the cost of the eNode B is really one of the many line items, and the incremental cost is not that much bigger. So I'll end my presentation here. I think that was the last slide.
Fantastic.
Thank you so much.
Thank you, Boris.
Yeah. Thank you so much, Boris, and thank you so much, Kadir, as well. I have a couple of questions here. I believe most of the ones that I received so far, they are more related to the product itself, to Magma, the software. I'll read them with our answers, and please feel free to chime in. And if anyone else has questions for both Boris and Kader, or even to myself, right, feel free to post them on the chat here, okay? So the first question we got is, would Magma support mocking, where a neutral host network could host a private plus Verizon plus AT&T PLMN IDs? The answer to that is, for now, no. We don't see a lot of demand. Like we didn't have a lot of channel partners and partners requesting mocking, but we do support inbound roaming. So you can create a network where like users from any of these networks could roam on a network, on a private network that you build, no problem at all. Obviously, I mean, Magma is open source, right? So if anyone wants to contribute what is needed for mocking, that's super welcome as well, of course. Second question we have here is, could Magma run local functions under an orchestration layer such as Anthos? And the answer to that is definitely yes. We are already working on like future releases with ONAP and OSM. And we could easily translate what we are doing with these two to Anthos as well, as long as there is market demand. So that shouldn't be much of a problem. And a last question that I got here was on N4 interfaces, if we are supporting as well N4 interfaces, because this was not shown on my architecture slide, right? So we are not implementing N4 directly because we are not building a separate UPF. But we are implementing an N4 equivalent functionality over gRPC. So there's like a technical document explaining why we made this decision. I can make it available to anyone who's interested. It's actually a document from the Magma Foundation, so it's public. But that's in a nutshell the answer. Talking about the design ideas behind this, right? So we only implemented 3GPP interfaces when we thought that that would be the best possible approach, right? To like a smaller core, right? That has to be distributed and it has to fit on a small footprint. If we were implementing each of the individual network functions with their standard interfaces, this would be a very large core, right? And then you would just have like be better off with a core from one of the existing tier 1 vendors in the market or whatever. So that was never the idea, right? The idea is to make use of what is the best technology, right? And HTTP2, in a lot of cases, that allowed us to reduce the footprint a lot while we're still having a lot of scalability, a lot of performance, and a lot of possibility to do high availability at a much lower cost. So that's why we went for it. There's one more question that popped up here. What about support for IMS? Yeah, so we do support IMS already, and we have a few implementations that people are using it. We just, we're not building the IMS components into Magma, right? Like this is like a third-party solution that in some cases we see adopted, for example, for voice, and it is supported, but it's not like that Magma itself is going to build all the different IMS network functions. Kader and Boris, I don't know if you guys want to complement any of these questions. I know that they were a lot more focused on the Magma as a software, right?
So I have a question maybe I can pose to either Kader or Boris, and that is, you know, if I'm a WISP and I want to deploy Magma, how do I get support if something goes wrong?
Subscribe to our support plan. So, I mean, part of the way that we monetize Magma is we, you know, sell subscription support. So we're not the only ones. I think that there is an ecosystem of vendors in the community that offers support, or, you know, hire people that know Magma and support yourself. That's the beauty of open source.
Yeah, thanks, Boris. From Wavelabs' point of view, you know, like I was presenting, it was, you know, we support the OpenX ecosystem. So we would really wanted to support our customers no matter which platform they wanted to install Magma, we really wanted to support them to realize their use case. So from our point of view, the long answer, the short answer for this is, you can always reach out to us. We'll be happy to help you with that question.
Thanks. Another question just following up is if I wanted to do a trial, what would it take for me to do a trial? How can I do a trial to make sure that this works and that it's going to be in my good work in my environment?
So there are many different ways you can do trials, of course. I mean, you can take the do-it-yourself route by simply downloading either the source code on GitHubs or some of the images that are going to be published by a lot of our partners, right, including the Magma Foundation. And I know both Boris and Kadir work on their own images, right, based on the Magma code. So that can also be an alternative, right? They sell kits that contain everything. There are partners who can sell the services of a fully managed services network, so you don't need to do anything. They build and operate for you. There are many different options, as I said. Boris, Kadir, I don't know if you guys want to complement.
Yeah, I mean, if you
go ahead.
So I mean, we have a kind of a prescriptive way for people to do trials. You can go to freedomfi.com/products, or you just select order button on the website, and there is like you can basically select all of the different components that you need to build like a POC for an LTE network. The gateway, a basic RF planning session, SIM cards, access to CBRS spectrum, and any support plan, including with like no support plan if you're just doing a POC. You can just click the checkout button and pay with a credit card, and you get your trial. And this is in fact how most of the early pilots that we do come to us.
And from Wavelabs' point of view, once you hit the button and if you have some troubles, you can always come to us. And we also, like I mentioned, we are very ardent proponent of OpenX ecosystem, right? Depending upon same size doesn't fit all. I was talking about that as well. So depending upon the use case, you might choose to install it in the bare metal, or you might choose to install it in the edge, or maybe in AWS Snowcone, Snowball, or even in AWS Regional for core network as a service. So there could be various different things that you might want to do based on your use case, right? So that's where we come in as Wavelabs, and we have kind of tested in most of the cases, right? We would be handy to help you from that point of view. I was in fact planning to share a couple of use cases, but I was running out of time. So probably, if you always can reach out to us, and we'll be happy to talk with you and see how we can help you.
We have a few more questions here from the board as well. I got one question. How about provisioning smartphones? Are UDU and CPE is from buy cells? Is it possible to have other options? And the answer to that is absolutely. I mean, Magma already integrates some network management and device management for buy cells, for example, because we were working with them as one of our early partners. But there are other partners as well that we are working with. And there are also the possibility of using the tools that these partners provide as well. So let's say if you want to use a radio from any other manufacturer, I mean, they all talk standard 3GPP interfaces, right? So it's S1A, and it doesn't, even though it's not managed by Magma, you can still use the management layer from that vendor, right? Which normally they license together with the radios. Some of our partners, the ones that we presented there, they even specialize in a few specific radios. So if you want to use, let's say, a tier 1 radio like a Samsung, an Ericsson, a Nokia, I mean, we have some of our partners who have extensive experience in doing this kind of like scripting for those radios, and they could do the integration and run it, and like they tested in their labs. And if you need integration with other SIM management platforms, for example, same thing. I mean, some of our partners like Amdocs, for example, they have their own SIM management. Others, like I think Boris can comment on FreedomFi, right? I know you have partnerships to do SIM management as well from other companies in the market. So this is a very open solution that like the building blocks are there, right? You can make a solution that's simple or as sophisticated as you need it, right?
Fantastic. Michelle, thank you. I think we're at the top of the hour here. I want to really thank Michelle, Kader, and Boris. And of course, thank you everyone for attending the event. We will share over email links to both Wavelabs and Freedom Fi, and also to magmacore.com, the website where you can see all the different use cases, and we'll also post this presentation online as well. Any other final words from anybody? Any other presenters?
No, thank you so much for organizing, and thank you again, Kader and Boris, for participating as well. Thank you all in the audience.
Thank you, Michael. Thank you, Boris. It was a privilege, and you know, those who need help, you know what to do.
Thanks, everyone.
Thank you.
Yeah.
Thank you.
Cheers.
Bye.
All right, thank you everyone. Bye.